それでは、残りの時間。
So we'd like to spend the remaining time to engage in some dialogue with you. And since we have Amory here, which is very fortunate for us, I would like to ask other presenters to make a brief comment about the presentation made by Amory. And regards to the construction materials, the integrated design should be established, and that's what Emery said. And as a consequence, energy and cost can be reduced significantly, and I think that was the message. And so that type of the integrated approach, and as far as Dr. Murakami was concerned, I have referred to the SDG approach, and I think there are some commonalities there. I'm sure there are also other points as well. But could I ask first the Professor Tanabe to make a comment?
So I will not follow the scenario, but the US and California. I have a question, Dr. Lovins. In Japan, if I wish to make a house, build a house, I will want to make a zero energy house. But if I don't have the money, but I want to make an eco-friendly house, and the central government says that because it will be costly to have PVs, as a basic human rights, could there be any restrictions? In the case of fire and earthquakes, in California, without if PV is mandatory or insulation, energy efficiency are mandatory, are there any such discussions in California in the USA? That's an area where there is some debate. But as I mentioned about a mandatory PV or stringent insulation, of course, this is related to the presentation of Amory, that it could be costly. Initial cost could be large, but it can be offset or recovered within a foreseeable period of years. But for would-be homeowners who do not have the money at this moment, in terms of finance support, if they do not have sufficient income, there must be some support. So financial support for those who do not have sufficient capital to enable such houses to be built.
PVs are mandatory starting in, 2020 on new California houses. And 2020 and 2030, depending on type of building, all new buildings must be net zero or better. Also, if you design right, as I was describing, you get to the European result, which is a passive house standard costs the same as a regular house to build, within about 2% either way, depending on local conditions and the skill of the designer. Initially, it cost something like 10 to 20% more, and it still does if you must pay for your designer's education. But then with experience, the cost rapidly drops to approximately zero because you leave out the heating and perhaps even cooling equipment. In a commercial building in the US, that's 9 to 12% of capital cost. So leaving that out is a big saving that pays for the things that get rid of it. Also, we have in many states, not all, a PACE bond, PACE, which you can read about at pacenow.org, which provides low-cost financing for efficiency in using energy and water in new or old buildings. And it's very cheap long-term money, which gives the owner positive cash flow from day one. Such a system, I think, could work very well in Japan, where you have a high savings rate. And this is very advantageous for the financier, the mortgage lender, because the loan to value improves and the risk of default on the mortgage decreases when the borrower has better cash flow. So you need less reserve on the balance sheet against default. Therefore, the lenders should find this interesting and should even give a lower interest rate to reflect the lower risk and share the benefit. One other thing that I've run across in my own house, is there anyone here from the insurance industry? Okay. Well, perhaps you could tell your friends in the industry. My insurance company will give me a discount on my insurance price if I detect a gas leak, if I detect a water leak, if I detect frost, which might burst a pipe. But they will not give me a discount if I have no gas or if the house is incapable of freezing. So they pay me for detecting a hazard, but not for preventing a hazard. So I wrote to the head of the insurance company and said, I don't understand why you're driving away your lowest risk customers. You should actually make this a new business line. As houses which eliminate these risks become more popular, you should offer a special package for those houses and you'll get all the business. And he wrote back, what a wonderful idea. When can I come visit? So maybe this idea could have some opportunities in Japan because of the wonderful work that you're all doing in promoting such buildings.
About the PACE, the PACE bond, I agree it will be effective. In the case of Japan, in order to borrow, you need the credit standing. So if you do not earn income, loan cannot be borrowed. But in the case of PACE, the credit is given to the house itself, to the residence itself, and therefore what is paid, it is paid as a tax on the property, which is the key point. So credit is given to the resident, and therefore it could be higher on the time of selling, but it's passive, and the house value will have risen, and therefore that could be offset. In the case of Japan, if such a system is available without initial investment, if the value of the resident rises, it will be very effective.
Advantage of the PACE bond is that if the house is sold before the loan is paid off, it doesn't matter because the loan goes with the house. It's not an obligation of the borrower personally.
Oyama-san, do you have any comment on this? No? So how about Mr. Takai?
Marie, it is a great honor for me that I have had this opportunity to meet you and hear directly firsthand. You have such an extensive knowledge, and I have to admit that I do not understand all. But about the buildings, integrated design for construction, there could be different meanings for integrated. For us, it would be construction or system engineering, and the suppliers of them, or the operators. Integration could cover multiple stages. Not only energy benefit, but there are other benefits like multi-benefit or co-benefits. And I fully appreciate those good aspects. From downstream to the upstream. So downstream before upstream, you said. I think that's something we can do more in Japan. For example, our Higashi Kanto branch office, initially, we start aiming at zero energy. And after the time, because of the comfort in the room, we think there could be improvement, or how the work style of our workers have changed. So from our perspective, does not start from the downstream. And the geothermal and the solar, about direct harvesting and utilizing, we emphasize that. But then the pump and the fans used for the transportation, maybe we could have done better. So the power consumption could have been smaller. I think I have learned a great deal, and there is much more we can do at the Higashi Kanto office. Thank you.
I thought your paper was wonderful today, and I want to emphasize the importance of the deep measurement that we saw displayed for this building. Something we need much more of. Meticulous measurement is the key to understanding how to make things better. When I first met Dr. Engineer Wolfgang Feist, who started the German Passive House Institute, he was visiting my house and realized then that with super windows you could not just shrink but eliminate the heating system. So we went back and did it in Darmstadt. 1.8 million buildings later, the story is obvious. But when I went to visit his building in Darmstadt, he was just completing the calibration of his model to predict the heat use at each hour of the year. And to get it within the last 1 or 2%, he had to account for the absorption of water vapor by the plaster, which would then give it up again, depending on temperature. And he had to account for the heat, which went into the water in the toilet tank and then left the house when you flushed the toilet. Yes, good German engineering, but we see here good Japanese engineering also is wonderful. And I'm looking forward to the honor of visiting this building Monday to see what I can learn from it. But let me ask you, I notice in your graphs there was some heat used in the winter. And I wonder if the total capital cost might have been lower with even more insulation, maybe air-to-air heat exchangers, maybe super windows, so that the building would not require heat. In other words, if you had made it thermally passive, might you have saved even more money and energy, or was this not practical? Perhaps it's hard to get super windows here.
In Japan, availability of super windows, the procurement back then, we did not have access to super windows at that time. For example, with a low E, we used a special gas in the cavity. There's triple glass or vacuum glass. There are other glasses available, but the height of the opening is quite high. Because of some conditions, at that time, in terms of the cost-benefit calculation back at that time, we could not choose that option, and the super window was probably not in our horizon. So just like housing with better insulation, I hope it will spread to non-residential buildings as well, including our own building.
You just identified a business opportunity.
Thank
you very much for the invaluable the presentation, Emery-san. And having listened to this, you have focused on the renovation, refurbishment a lot. And I think you have introduced a lot of advanced undertaking. Myself, I am looking mainly at the new detached houses in Japan. In the case of Japan, detached houses or the existing houses, renovation is, there isn't really a market for that as yet. And I wanted to receive your advice. And one of the reasons the housing energy performance, the indication or presentation, that's not made mandatory as yet. So less than 10% of the buildings will show the energy performance for that building. So the general consumers do not recognize the environmental performance, and so they cannot work on renovation based on those numbers. But based on your know-how, Amory-san, and in the U.S. or Europe, the energy performance indication is widely spread. And to what extent the general consumers understand the energy performance indication? Is that becoming motivation for people to renovate their houses? If you could give your advice as to the direction that Japan should be heading towards in the future.
It depends on where you are in the country. In some places, energy rating systems are well understood. All the appraisers take them into account. They are considered in whether to give you a loan. The market has really digested it. In other places, it's completely unknown. So the way you are starting with the building rating systems, I think, is very good. And if, even if it's voluntary, I believe it was Berkeley, California, that introduced a voluntary energy rating system with 1, 2, 3, 4, or 5 stars. It was entirely voluntary, and yet soon it became difficult to sell or rent a house that was not rated, because people would realize, this doesn't have a rating. I wonder why not. Another approach, which California and New York have used, is that when you are going to sell or rent a house, you must make available for inspection, I think it's the previous year of energy bills. But this has to go with a public information campaign and with educating real estate brokers, including leasing brokers in the commercial sector. And then you have to educate the leasing brokers when they calculate pro formas for a building to use the actual measured energy use and not some average assumption. There are about 25 parties in the real estate value chain, commercial real estate, each with perfectly perverse incentives. They are systematically rewarded for inefficiency and penalized for efficiency. So if you wanted to devise a system that would make buildings cost more to build than they should, use 10 times the energy they should, and be less comfortable, healthful, and pleasant to be in than they should be, it would be hard to improve on the system we actually have. So that is full of business opportunity. Each of those market failures can be turned into a business opportunity. In housing, it's different. It's more complicated, more granular, but the principles are the same. And I want to comment also that in our new office building, we did something rather related to a thing I mentioned briefly, and that is to pay the architects and engineers for what they save, not what they spend. We call this performance-based design fees. And it has a very valuable effect on design. So in our building, we made the first use in a small building, it's only 1,500 square meters, of a process called integrated project delivery, which is commonly used in America in big complex buildings like hospitals. But now we know it works in small buildings. And as a result, our unusual building was a little ahead of schedule and a little under budget. How does it work? Well, the owner, the designers, and the builder all have perfectly aligned incentives. They are rewarded uniformly for common success. They are penalized uniformly for common failure. There's no finger pointing. They won't sue each other. They can put people in each other's office for better coordination. They all have the same information on the same software at the same time. And if the builder has a question for the architect, it will be answered immediately because delay also hurts the architect's profits. This alignment of incentives is extremely important, and it means that then the builder will be at the design table, contributing her knowledge to the design process, rather than having the designer design something and throw it over the transom to the builder and say, here, build this thing, we'll take the low bid, which yields a very bad result. But if you have all three parties fully combining their efforts in an integrated design process, it works better and it costs less. And I feel sure the same must be true at some level for houses also.
どうもありがとうございました。
Thank you very much.
私も少し
I would also like to ask Amory-san with a certain example. Now, in Japan, insulation or high insulation houses are not all that popular as yet. And I think the general people don't know good houses, houses that are not cold, and I don't think they know what that is. And that's because people tend to be able to withstand cold houses. Amory-san, you know Japan well, so if you consider that, in what way people tend to continue to withstand cold and then don't complain to the house. They don't complain to the architects. And that may be the cause to an extent. What do you think?
Well, I've also been in old paper houses with the katuts, and it's a wonderful invention if you live in a paper house. But if you live in a, say, masonry house, why should it have air leaks? Why should it not be insulated? Because at that point, you've already gone away from the traditional openness to nature. You were walled off. And you wouldn't keep food for long in a refrigerator with no insulation. The food would spoil. I mean, the principle is obvious, but I think many people have not experienced the extra comfort and health benefits of a good house with insulation. And when I first came to Japan, maybe 40 years ago, I think in Hokkaido you had to have 10 centimeters of mineral wool, but in Honshu, almost none. Yeah, so things are improving slowly. Do be careful, of course, when you insulate to handle humidity. There is a lot of art as well as science around air barriers and vapor barriers. And if you don't get that right, as you have more insulation, you could have mold and other problems in the walls, which would spoil the reputation of not just the builder, but the technique. In our building, our new one, we use structural insulated panels, which I think would have a lot of application in Japan. Just 2 sheets of fiberboard and about this much foam. And it was sprayed with a special paint that penetrates in at almost a microscopic level to plug the cracks. So we had 0.37 air change per hour at 50 Pascal, almost twice as airtight as a passive house, one of the tightest buildings ever measured. And it's much easier than doing the old barrier of polyethylene and requiring very careful craft labor to seal all of the joints. So, in fact, another technique that I think is commercial now, Lawrence Berkeley National Lab made an aerosolized chewing gum, which you can spray into ducts, and it goes where there is a leak in the duct and solidifies at that point. There was an experiment done about 5 years ago where they took some big piano crates for shipping pianos, very big boxes, and sprayed it in to see would it go where the cracks are and not deposit on the rest of the box, and it worked. So again, maybe with such materials, it's easier to fix up old houses. The question I have for retrofit of Japanese houses is, can you use something like the Energisprong Dutch technique I showed of dropping a new wall, a super insulated wall and roof onto the house that's industrially produced? Or is it impossible in many places because the house is built as close as possible to the boundary of the site?
About the housing insulation and the subsidies are available, and therefore, if there is insulation, indeed, performance is higher. And there is very thin places, and vacuum insulation technology is available. But as was mentioned, Ms. Nishida, many people may not know the comfort of warmer housing in the first place. But I think it is starting to change. Like 50,000 top-run housings are being built, or ZECH houses becoming available per year. So people are getting to know more about the comfort of warmer houses. Japan is known for long longevity. We talk about the 100-year life. So our post-retirement life is long. So to live healthy, to have a healthier longevity with a comfortable housing, that importance has to be appealed. So non-energy attraction has to be appealed. So before the retirement, money should be spent in order to better the envelope and to improve the housing environment.
Well, unfortunately, we are starting to run out of time. So lastly, I would like to receive a very short comment from each of you. Decarbonization is where we are heading towards, and good houses and good buildings. In order for us to create these, what do we need to do now? And if I could ask Oyama-san to start very briefly to respond to this question. So let me be brief. Decarbonization is something we need to resolve in our generation. It's not an issue that can be left to the next generation. So in that sense, for the construction and the building industry, as we are involved in this industry, we need to have a long-term thinking. We have been given opportunity to contribute towards the future. So as the industry, we want to deepen the discussion towards decarbonization so that in 100 years' time or the 200 years' time, our current generation will be thanked. That's all from me.
Mr. Takai? It was a very thought-provoking experience for myself, residential and non-residential. For the residential, I think it is advanced, and the envelope, it is becoming better, and ZECH houses are improving. There's the labeling, as Professor Tanabe mentioned, there's lots of residential labeled, and a virtual power plant utilized. In the non-residential, there are efforts ongoing, but still it is lagging behind compared to residential. It is definitely lagging behind residential. So non-residential should learn from the residential, which means we also will have to do better. Thank you. I see Professor Nakagami of Energy Efficiency Committee, but reducing energy consumption, that would not be enough. So just bearing, perseverance, and consuming less, that is not enough. Renewable is accessible more than ever, so better use of renewables. Energy efficiency and better efficiency is what we need to pursue. When there is lots of mikan mandarin that we harvest, we can save and eat one by one. If you are given a lot all at once, you might enjoy the luxury, but at the same time, if you can share this fruit with your neighbors without depending on fossil, we can decarbonize. And the benefit is we live longer in a healthy way. It's just like a Japanese washoku, which is very healthy.
We could not have had this meeting with these wonderful speakers and examples 5 or 10 years ago. So, having been involved in this discussion in Japan for 40-odd years, first of all, I want to thank my colleagues and all the speakers for the impressive progress being made. And while we work on making things even much better, we should take some satisfaction in having real examples to talk about now that we didn't used to, and they should inspire us all. Japan can do things faster than anyone once you make up your mind to change. That takes a while. It's kind of like the subterranean movement of tectonic plates, and things drift very slowly and nothing seems to be happening, and then suddenly there's an earthquake. This is how change happens in Japan. I see signs that that rapid phase of the change is approaching because the logic is so irresistible. The skill is there. We lack certain other ingredients. But we know, because Basho tells us so, that frogs jump far in Japan, you know, fura ikeya. We're still waiting for Mizuno Oto. So those of you who care about the sacred sun on the flag, who know the millennia of wonderful creativity and skill in building in Japan, we need to put these pieces together for a secure, healthy, prosperous society that can lead the world in that hyaku. Thank you.
Well, there is nothing else for me to add, but lastly, the Renewable Energy Institute and the other NGOs now have launched the climate initiative. Non-state actors, so various organizations outside the government, companies, NGOs, and the local public organizations. All these the entities coming together to act together. We have started to create a network, and I encourage you to participate. And on Friday next week, we have a large summit at Toranomon Hall. So please look at what we do, and not only look at what we do, please participate so that we can broaden the scope of these activities. Today, they were memorable, and we heard about things that we need to continue to think about going forward. I'd like for you to take that back with you, and so that we can again have discussion at the next opportunity. Once again, thank you very much.